So in section 13.4, we're going to go over something which has kind of a lofty title, nonlinear systems of equations. Basically what that means is that we're solving where a couple of different graphs intersect each other. And there's a lot of possibilities depending on the shapes. To illustrate that, we're going to take a look at this circle and hyperbola. We're actually going to change the size of our circle. We're going to change its radius by using this little slider here. Now, right now, the way we look at things, it doesn't look like there's any intersection between these two, and there's not. So this nonlinear system of equations wouldn't have any solutions. But if instead of a 1 here, if I made that 1.5, then things change a little bit. Then the graphs touch right there, touch at 2 and 0, and you've got exactly one solution. All right, let's make our radius bigger, and this time I'm going to do that by dragging. And if I slowly drag this, I'll see that I got more than one solution. I've got 2 solutions. So one down here and one up here. It's where the graphs cross each other. Not some particularly nice numbers, but it's okay. There's still solutions nonetheless. So we start out with 0 solutions, then 1, now 2. If I make this exactly 2.5, I'm thinking that I'll get 3 solutions. So we got 1 here, 1 here, and 1 here. 3 solutions. After I get past 2.5, now how many solutions do I have to this nonlinear system of equations?
4.
Yeah, 4 solutions. Up here, down here, top right, and bottom right. So 4 solutions. And that's what we're looking for when we solve our system of nonlinear equations. Now you can solve some of these things by graphing. And one of the problems in the homework is pretty simple because they just give you the graph of this. And it looks like this. You just need to come up with the coordinates. There's 4 coordinates, and those 4 coordinates are your solution. What if they don't tell you what the graph is exactly? If they just give you some choices, like in this nonlinear system of equations, you've got 4 different choices, so which one is it? I guess in that case, what I would do is I'd try and figure out, first of all, what the graphs look like, at least to some small extent. And then maybe by process of elimination, we can figure out which one we want. So let's start by looking at those 2 equations, x squared plus y squared, or x squared plus 9y squared equals 9. What equation is that yellow one up here? What's its graph going to look like?
It's going to go left to right, or left and right.
Not the top one. Why not the top one? Why isn't the top one a hyperbola?
It's an ellipse.
It's an ellipse. What makes it an ellipse and not a hyperbola?
It's an addition instead of a subtraction.
Yeah. If that was a subtraction like it is down here, that would be a hyperbola. But up here, because it's an addition, that's an ellipse. So that's the big difference between the 2. Both of them, oh, this should have a square term, by the way. Both of them have 2 square terms, but this one has a plus between those 2 square terms. They have the same sign, so it's an ellipse. We still have to figure out which graph is which, and I would just take one of these and put them in standard form. My morning class did the hyperbola, so I'll do the ellipse here. X squared plus 9y squared equals 9. This is not quite in standard form yet. What would I do to put that in standard form?
Divide by 9.
Yeah, divide by 9. So that gives me x squared over 9 plus y squared over 1 equals 1. And that's pretty good, although I'd probably tweak that one more. Christy got us this far. Can anyone put us across the finish line? What do we need to do to make this a little bit more user-friendly in terms of looking at the graph?
Change the denominators to 3 squared and 1 squared.
Yeah, 3 squared and 1 squared. So that's basically telling you what the graph of this is going to look like, because it has a center at 0 and 0. And then in the x direction, you're going to move 3 to the left and 3 to the right, and then up 1 and down 1. Now, since we're reviewing these shapes a little bit, what can you tell me about the hyperbola here? Can you tell me anything about the hyperbola here? I'll give you this much as a center at 0, 0.
It opens up and down.
Yeah, it opens up and down. And that's key to know that. That helps us eliminate a couple of the possibilities. So it can't be this one. There we go. Can't be that one, nor can it be the one below that. This one can't be that one. And this is just a software error. There we go. So we're stuck between these two. But in thinking about our ellipse, we can actually narrow it down even further. Which one of these graphs does it have to be? Top one or the bottom one? Well, let's look back here. To find the vertices, I'd move a direction of 3 to the left of center and to the right of center. In other words, I should have vertices at 3, 0 and -3, 0. Like this. And then another one at +1 and -1. So my graph should look like that. Which one of these fits the bill? Top one or the bottom one?
The bottom one.
The bottom one. Perfect. So the bottom one works. And once you've realized that it's the bottom one, your solution is really those 2 points there where they intersect. So 0, 1 and 0, -1. If you're like still unsure, if you're like go through all that and not sure that those are your answers, how could you prove to yourself that you actually got those right? That this is actually the solution? Any suggestions?
Professor, I don't know if I'm going to answer your question, but at the problem, the way it's written out, x squared is first. So isn't that like a hint that we know that it's going to go left to right?
That only helps if it's a hyperbola. So in an ellipse, you could write either term first and it's still going to have the same graph. But in a hyperbola, then the order is going to kind of make a difference. Well, actually, which term is positive is really what makes the difference, not so much which term goes first. Because I could write that parabola, that hyperbola, I could equivalently write it as -x squared plus 9y squared equals 9. That's still the same hyperbola. It's just that I've written it in a different order. What makes it a hyperbola is that one of these is positive and one of them is negative in terms of your squared terms. Well, let me help you out here a little bit. What I was looking for is that if it's a solution, you should be able to put those numbers into the equation and find that they work. So if I take the point, say 0 for x and 1 for y and put it into my equations, it should work in both of them. So here's just kind of a quick demonstration. 0 squared plus 9 times 1 squared equals 9. Oh, that works in that one. And then you have to check it in the other one as well. But this one and this one should work in both equations. So you can double check it if you're feeling a little bit nervous, or you just want to be very careful. Looking okay on that one?
Yep.
Now, quite often what you'll end up with is a system of equations you can't necessarily solve by graphing. And if you can't solve by graphing, then you need to do something like substitution. So let me try this one. By the way, what are these two graphs going to look like? What's that first graph going to look like? X squared plus y squared equals 25. No idea?
Is it an ellipse at all?
It's kind of a special case of an ellipse. And let me demonstrate that to you. So I'm going to go over to, let's see.
Is it
This
a
way.
circle?
Yeah, it's a circle. And the thing about circles is that they really are special cases of an ellipse. So right now, this is a circle. But if I change one of these denominators, so the denominators here are 4 and 4. If I change one of those denominators so that they don't match, then it's no longer going to be a circle. So if I make that denominator smaller, I get this narrow ellipse. And I can make it even narrower by changing A. So it's only when those two things are equal. For instance, I had 5 here and 5 in the denominator here, that I get a circle. So the circle is a special case of an ellipse, just like the square is a special case of a rectangle. All right. So if the coefficients are both positive and the same, so a 1 and a 1, both positive and they match, then it's a circle. How about the graph of this one down here? What's this one going to look like? That's just going to be a line. I would suggest you solve this by substitution. If I take that x term and put it on the other side, I get negative x plus 7 for y. And I'll take that value for y and substitute it into the top equation and then see about solving. So here, that goes into the top equation. That'll give me something like this. X squared plus something squared equals 25. The tricky part here is squaring this out. You can't just get x squared plus 49. That doesn't work. What you have to do is you have to be patient and FOIL it out. Minus x plus 7. So it's x squared plus negative x times negative x gives me what?
Two x squared.
Close.
Just x squared.
There you go, x squared. And then negative x times positive 7 gives me negative 7x. And I get that same product again in the middle. And then finally a plus 49. And thanks for the help back there. You've got like terms here and here. And you got like terms here and here. Let's combine those. That gives me 2x squared minus 14x plus 49 equals 0. Well, not 0. How about 25? If I do want 0 on the right-hand side eventually, so if I subtract 25 from both sides, that gives me what I want. A little Freudian slip there maybe, which is the 0 on the right-hand side. You've got a couple ways to solve this. You can use the quadratic formula, which, always works, which is great. I wouldn't use a quadratic formula on this one though. Any suggestions for this one?
Can
I'd
you
start
take
by-
out a 2?
Yeah, perfect. Factor out a 2. And you can pretty much ignore that 2. 2 is not going to make this 0. So I'll just leave that there. Well, what's in the middle does factor as -3 and -4. You've got the product of 3 things that equals 0. So where does x minus 4 equal 0? What value of x?
4.
+4.
4. Where does x minus 3 equal 0?
+3.
Can 2 equal 0?
No.
No. So those are your 2 solutions. Now those are the values for x. Keep in mind, way at the top, we had y was negative x plus 7. So if I plug in a 3 here, -3 plus 7 gives me y equals 4. And -4 plus 7 gives me y equals 3. So those are your 2 solutions. Yay. All right. How are we looking on that one? Doing okay there? That's the substitution method. There's also the elimination method, but the elimination method wouldn't work too good here. I can't easily add these 2 equations together in any form to get something to drop out. Now the elimination method, I prefer to call it the addition method, but whatever, the book WebAssign calls it elimination. To me, it sounds like a mafia hit, but whatever. Let's solve one by elimination. Kind of like the last one, maybe we'll start out by looking at these equations and see if we can't figure out what equations they represent or what figures they represent. So let's look back here. X squared plus y squared equals 17. X squared minus y squared equals 15. What shapes are we looking at here? Anyone?
The first circle.
All right, Grace got the first one. That's a circle. Excellent. In fact, it has a center at 0, 0, and radius is the square root of 17. How about the second one? What's this one going to look like? Someone different. Your chance for fame. Come on. Propel yourself to stardom. What graph is this? Circle, parabola, ellipse, hyperbola, line.
Hyperbola.
Hyperbola. Excellent. Which direction does it open?
Left and right.
Left and right. Perfect. Kind of like the other one, its center would be 0, 0. This one is beautifully set up for the addition method. All we need to do is add those 2 together. Sometimes you're going to need to multiply one equation or the other equation or both so that you get what we're going to get here, which is some terms to cancel out. 2x squared equals 32. X squared equals 16. If you do x equals 4, you probably make me unhappy, especially on a test. Don't put x equals 4 on your paper and then get the right solution on WebAssign. What's missing here?
Square root sign. Or plus or minus 4.
There you go. So to solve here, kind of the step that I didn't do is x equals plus or minus the square root of 16, which is plus or minus 4. So there's really 2 solutions there. let's find out what happens when x equals 4. X squared plus y squared equals 17. So 4 squared is 16 plus y squared equals 17. Y squared equals 1. Subtracting the 16 from both sides. What does y equal?
Plus or minus 1.
Excellent, plus or minus 1. Now let's keep track of what we got here. When I set x equal to 4, I got two possibilities. I got y was equal to positive 1 or y was equal to negative 1. You've got to go back and do the same thing with x equal negative 4. Now maybe you can see that if x is negative 4, it's really going to work out exactly the same way. So if I put in that negative 4 here, I'd end up with 16, and same as before. This time it's going to be negative 4 for x, and that gives me two solutions for y, 1 and negative 1. Now, unfortunately for you, this is not a face-to-face class. A lot of times people give me plus or minus 4, plus or minus 1. I'm unhappy with that. You're not going to get full credit for that. I kind of understand what you mean, but you need to list them all out. So those 4 would be your solutions. You have 4 points of intersection. So that one look okay?
Yeah.
All right. Do you want to practice one more by substitution or one more by addition? Doesn't matter to me.
Can we do one more by substitution?
Which one?
One more by substitution?
Sure, sure. I'll actually pick the harder of these two, which is the second example. I think there's one like this in your homework, so it might not be a bad idea to go through this one. So here we go. Here's your two equations, two nonlinear equations. There's actually a couple ways you could solve this by substitution. You could get the y by itself by moving the 9 to the other side, or moving the y to the other side and the 9 to the left-hand side. So something like this. That's how we're actually going to solve it. You could also solve it by moving the 4y term to the other side, dividing by 4 and getting y equals 3/4 x. That would be a different way to substitute. If you got this expression, you'd substitute it in here. Taking this expression, you substitute it in here. They're going to give you exactly the same thing. It's just a matter of preference. Most people don't like dealing with fractions, so that's why I went with this substitution. But you're free to do either one you want. Now going with this substitution here, I'm going to take this expression for y and plug it in here. So I'll have 3x minus 4 times all that. So it's going to look like this. 3x minus 4 times this expression for y. So then you got to distribute that negative 4 to all three terms here. So here, here, and here. And that'll give me 3x minus 4x squared plus 4x plus 36 equals 0. And there's like terms here that I can combine. 3x and 4x give me 7x. So there you go. Negative 4x squared plus 7x plus 36 equals 0. Generally speaking, it's not terribly fun to try and factor something with a negative coefficient here in front of your squared term. So what I did to make my life a little bit easier is I multiplied everything by -1. So -1 times 0, that's still going to be 0. But on the left-hand side, -1 times positive 36 makes it negative 36, and so on. It's just going to change all those signs. So you get something that looks like this. You've got two choices here. And from a morning class, I did factorization. This class, maybe I'll do the quadratic formula, because factoring is not terribly easy. If you use the AC method, you multiply the outside numbers. 4 times -36 gives you -144. And then you need two numbers that multiply to -144 and add to -7. Fortunately, I've been doing this stuff so long that I kind of see these numbers, etc. So you can split up that as -16x and 9x, factor, factor, factor. But let's do it a different way. Let's apply the quadratic formula. The problem with factoring is that a lot of people aren't very good at it, and the numbers are getting kind of big. And the real problem is that you can spend a lot of time and effort in trying to factor this and find out, oh, wait a minute, it's prime, it doesn't factor. And then you're gonna have to go back and use a quadratic formula anyways. So my kind of compromise on this is I'll look at it for a minute. If I can figure out how it factors, great. If not, after just a few seconds, I'm gonna bail and use a quadratic formula. So let me remind you of that. Fortunately for you, I won't sing this to my favorite fight song, but I've heard people that say, oh yeah, my instructor used to do that. Does anyone here have an instructor that would sing the quadratic formula out to them? Some tune? I even heard it to Pop Goes the Weasel. But
Hi, baby.
yeah, all right. Anyone want me to sing it? Don't answer that. All right. So negative of -7 plus or minus -7 squared minus 4 times a, which is 14, or is 4 times -36 over 2 times a, which is 4. Oh, it's going to be kind of messy here. The double negatives cancel, so I get 7 plus or minus the square root of 49 plus 16 times 36. I have to bail on that one for a second. 16 times 36, 360 plus 216, 576? I think so. I think that's right. 16 times 36, yeah, 576 over 8. So 7 plus or minus square root of 625 over 8. And it's at this point that you know, it could have factored. Why do I know it could have factored? Because the square root of 625 is a perfect 25. In other words, if this number is a perfect square, you know it could have factored. So, not that you have to factor it that way. There's two possibilities. There's the positive case, which is 7 plus 25 over 8. And there's the negative case, 7 minus 25 over 8. So that's 32 over 8 gives me a nice even 4. And this is, let's see, negative 18 over 8. And that gives me negative 9 over 4. Whew. Don't worry. I promise not to put any more than 10 or 11 of these on the exam. Now, regrettably, we're still not done. We're almost there though. Any questions or thoughts on what we got here so far? There's one last thing to do. We need to figure out what y is. Remember, we did our substitution, or one of the possible substitutions is y equals 3/4 of x. I'm going to use that to figure out what y is. 3/4 of x. If I plug in a 4, 3/4 times 4, the 4's cancel, I get y equals 3. So 4 for x, 3 for y. Okay. How about -9/4? Well, let's try that one. Y equals 3/4 times -9/4. -9/4 gives me -27/16. So -9/4 for x, -27/16. Yay. Nice, 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 nice. Comments or thoughts on that one? Perhaps a little bit more than you're asking for when you're asking for one more example, but it was a good one. It went over a lot of stuff, and it doesn't hurt to review the quadratic formula in advance of your final exam. If you're not counting on the final exam having a quadratic formula problem, you might want to think again. Any other comments or thoughts here? All right, let me put you in your breakout rooms.